This is the first example for the conservation of angular momentum. Okay, so the problem that we are solving is a wheel that is rotating and translating. So rotating and translating. So we use the velocity at the gravity center without slipping. So because it's without slipping, we know that Vg1 is equal to R omega 1. R is given. This is 0.2 meter. So Vg1 equals 0.2 omega 1. The question is what is Vg1 if the wheel will roll over this little obstruction there? And this little obstruction there at the height of 0.03 meter. That's the questions. We have one more information. That's Ig for this wheel, the mass moment of inertia, that is 0.156 kilogram time meter square. We have all these informations. How do we approach this problem? So what we will look at is before the impact on the obstruction and just after the impact of the instructions. So let's draw the principle of impulse and momentum. Okay. I forget, angular. And let's see if the impulse, if we consider the impulse. Okay. So the principle, it's H1, we'll see at which point, plus the sum of the moment dt, we'll see at which point, it's equal to H2 at the angular momentum. Let's draw our diagrams before finding the point that we want to use. Let's look at the impulse. So we have the integral of w dt. We will consider that we have left, okay, we have left there the ground. He has hit the step a little bit. So we have a force there, normal force, normal impulse, F dt. Okay. Ai. So that's the force. Let's call this point A. Okay. The weight, we will be able to consider that it's small and negligible. So because it's small, we can consider it non-impulsive. Okay. So the only force that creates an impulse and a big impulse is this force, the contact with this little step. What we can do to avoid that is instead of using the force, we will use the moment, and we will use the moment about the point A because this impulse is going through the point A. Okay. So what we will use is H A1 plus the sum of the moment about A dt is equal to H A2. Okay. So everything about the point A and A. Okay. So initial position, we need to look at initial velocity, final velocity for the angular velocity omega 1, omega 2. Now for Vg. Just before we touch the little step, Vg is horizontal, and we say that Vg1 is equal to 0.2 omega 1 because that's 0.2, right? Just after the impact, the IC, the new IC, so the IC was there, but now the IC is the point A. So it means that Vg2 is going up. Okay? So that's what we need. We are in general plane motion. Okay, so we need to find the formula for general plane motion for this one. at A, and something general plane motion at A. Okay, so what we have HA1. So HA1, this is equal to the IG omega 1 plus the MVG1 times the D1. That is a distance between VG1 and A. Okay, so I'm doing this one. So the HA1, it's equal to the IG1. We know it was 0.156 omega 1 plus the mass. Oh, I forgot to write the mass. The mass is 10 kilogram plus 10 kilogram times VG1. And what about D1? D1 on the initial position, this one, is a distance between the point A and VG, this distance D. That's D1. And we know that the height of the steps is 0.03. So D1, it's 0.2 minus 0.03. Okay? Let's keep only omega or only VG1. Let's use VG1 because the question asks to find the minimum VG1, so the wheel is able to roll over these obstructions. So the HA1 is equal to 0.156. We have VG1 equals 0.2 omega 1, so we can write that 5. Let's use the same color. So 5 VG1 is equal to omega 1. So we will replace omega 1 by 5 VG1 plus 10 times 0.17 VG1. And let's simplify this. Oops, let me grab my calculator. So we have 0.156 times 5 plus 10 times 0.17. That's 2.48 VG1. Okay, so that's the angular momentum of the wheel before touching the step. Okay. Here we go. The impulse, that will be fast because the impulse, when we use the moment of the force times dt about the point A, is going through the point A. So this is 0 because it's going through the point A. The moment of the force about the point A, because the distance is 0. So this one is just 0. That's why we use the conservation of angular momentum instead of the principle of impulse and momentum, is because we use the right point, the point A, where the only impulse force that we have is going through. So this is 0. So let's look at now HA2. HA2 is equal to IG omega 2 plus MVG2 D2. General plane motion, so we need to include the rotation and the linear velocity time the mass and time the minimum distance. So HA2 is equal to 0.156 omega 2 plus the mass of time VG2 time D2. What is D2 now? This time D2 is there. That's D2. And this D2 is the radius. So this is 0.2. That's the radius of the wheel. So we have HA2, that is equal to 0.156. We will replace omega 2 by 5 VG2. 5 VG2 plus 10 times VG2 times 0.2. So we got HA2, that is equal to 0.156 times 5 plus 10 times 0.2. This is 2.78 VG2. Okay. With those two equations, we can say that HA1 is equal to HA2 because of the impulse that is 0. So we can write then 2.48 VG1 is equal to 2.78 VG2. That gives us either VG1 is equal to 2.78. Yeah, it gives us VG1 equal to 2.78 divided by 2.48 VG2. So VG1 is equal to 2.78 divided by 2.48. This is 1.12. So VG1 is equal to 1.12, 1 VG2. Okay. Let's stop 1 second there and let's think. Does that make sense? So what does that say? That VG1 is a little bit more than VG2. Yes, that makes sense because it's before impact. So there is a little bit of velocity that is lost after touching the step. Okay, so the VG1 should be a little bit more. We have two unknowns. We need one more equations. And there's one thing that we use already, but not a lot. We will use now the conservation of energy theorem. Oops. To get a little bit. Oops, I'm sorry. Let me do that again. That's weird. Okay, I will do one step at a time. Maybe that's my picture that are, oh yeah, maybe I need to take more there. Bigger? Yes. Okay, let me put them exactly what they should be. Here we go. So now, to find VG2, we will use the conservation of energy. Okay, so we will use the conservation of energy between T2. So this is V2 T2 kinetic energy plus V2. It's equal to T3 plus V3. Okay. In this case, there is no spring, so V2 and V3 will be only VG2 and VG3. Just a little reminder, VG2, it's equal to the potential energy. And you have the formula Vg, it's equal to plus or minus W times Y. Be careful, that's an uppercase V and a lowercase g, potential energy. That's not the same than Vg and the little velocity, the velocity. Okay, so at T2, remember, we have the Vg2, we have the omega 2, and at T3, we have omega 3. And the velocity Vg3, that is back horizontal because we are on the top of the step. Okay, and we know that the little step is 0.03 meter. Okay, at the point G and at the point G. This is general plane motion. So for the kinetic energy, we have for this one T2, we have 1/2 of mVg2 plus 1/2 of Ig omega 2, right? How much is that? Let's find that. T2 is equal to the 1/2 times 10 times Vg2 square plus 1/2 of Ig, that is 0.156. And omega, we still have Vg, it's equal to 0.2 omega, and omega equals 5 Vg for both of them. Okay, so this is 0.156 times 5 Vg2 square. Okay, so we can simplify everything and we find, so we have 5 plus 0.156 times 5 square, don't forget the square, and divide by 2. That gives us 6.95 Vg2 square. Okay, that's T2. That's T2. Now let's find T3. How much is T3? How much is T3? How much is that? The questions is, what is the minimum velocity Vg1 so the wheel can roll over the obstructions? So it means that the minimum Vg3 and the minimum Vg3 will be 0 and omega 3 will be 0. Anything more than that, the wheel will roll over, but that must be at least 0. So we have T3 that is equal to 0 because we look for the minimum value, minimum of Vg1. So minimum of Vg2, so minimum of Vg3 too. And the minimum is 0. If it's less, it will not go over, it will go back. It will stop there. So we have T3, T2, and T3. Now we are missing Vg2 and Vg3. So for Vg2 and Vg3, we need a datum. We need a datum. And the datum that we can use, and you know what? I will use the same datum that my students yesterday. I think it's a good idea. Let's use this datum. The only thing that you need to make sure is to use the same datum for both velocity, for both initial and final velocity. So the datum is, so this one is the y at 0.2. And in this case, the y, that's the 0.2 plus 0.03. So Vg2 is equal to W times 0.2. And this one is W times 0.2 plus 0.03. Okay. So we have Vg2 that is equal to 10 times 9.81 times 0.2. And this one, Vg3, is equal to 10 times 9.81 times 0.23. So let's write this. So 10 times 9.81 times 0.2. This is 19.62 joules. And 10 times 9.81 times 0.23. That's Vg3. It's equal to 22.563 joules. Okay, so we have T2, T3, Vg2, Vg3. Oops, we can use our conservation of energy theorem. So we have T2 plus Vg2. That is equal to T3 plus Vg3. So we have 6.95 Vg2 square plus 19.62 is equal to 22.563. Okay. You play with that and you find Vg2, don't forget the square root. Oops, so square root of 22.563 minus 19.62, everything in parentheses, divided by 6.95. This is 0.651 meter per second. This is Vg2. And we have Vg1. Let's go grab the formula that we found before. This one, boom, 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 boom. Vg1 equal 1.121 Vg2. So Vg1 is equal to 1.121 Vg2. So we got Vg1, we replace Vg2 by 0.651. So time 1.121, 0.729 meter per second. There we go. So that means that to roll over the little obstructions, the wheel, this Vg1, should be 0.729 meter per second or more, and your wheel will roll over the obstructions, will be strong enough to roll over the obstructions. So just to repeat what we did, we use the principle of impulse and momentum, but because we use the point A, we can consider that the angular momentum created, the angular impulse is 0. So it's like applying just the conservation of angular momentum. We find the relationship between Vg1 and Vg2. And after that, we apply the conservation of energy between the time 2 and the time 3. We got Vg2, and we go back on the formula for Vg1, and we find Vg1. So one step at a time, and yes, that's hard to guess what you need to do, but one step at a time. Draw your diagrams. Diagrams help a lot. Draw your velocity, see your directions, and ask some help from your teacher if you need. And that's it for this long problem. Thank you. Bye-bye.